What's going on, y'all? It's your boy coming back at you again with another episode of the Coding Therapist. Man, I'm excited to continue with my series. It's also on YouTube, and you can look me up on YouTube as the Coding Therapist. I love to do these series for students that's coming up in like Code to Dream or anybody that's wondering on YouTube, right? So we're gonna tackle a problem in LeetCode. This is gonna be real timing. This is not gonna be the short video that you used to seeing where people already figured it out. I've been working with sliding windows, so I want to look for a sliding window problem. So that's what we're going to do today. All right. So let me share my screen. All right. So we're going to be going through the steps of how you break down a problem, starting from the umpire method. I think it's very important to understand the umpire method because when you first start getting into solving technical problems, you want to have a method, right? You want to just like you're getting ready to go to work in the morning. You're gonna take a shower, brush your teeth, put on your clothes, and it's almost the same type of thing every single day. And you start doing it secondhand, right? And you won't need to exactly just write everything down. But I think with technical interviews, you should continue to need to take notes as the problem is either stated to you or given to you where they have written it out. A lot of companies, especially FANG companies, they do, Google Docs where you won't have the syntax correction and all of those things or the ability to run. So I think it's important to understand that so you can get your head wrapped around different methods and common algorithms. All right. So right here, we're going to go ahead and read this problem. So given a binary array of nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. Okay. So this is how I like to do. Give them a note in Python here. Um, understanding. I like to add one in here, keywords. Keywords is very important for me. Um, what we're gonna do to plan and then implement, right? So these are the steps that we're gonna break down. So what I'll do here is spell it out for you. I think that's important, right? Understanding, and then we're gonna do input, um, output, constraints, and edge cases, right? So the input is a array of, but well, binary array, right? Binary array. So that's letting us know zeros and ones. That's how a computer listens to. That's how we talk to computers, right? One is on, zero is off. I know you probably have heard of that. So binary array um of I ain't got to say of one, just binary array. And then output wants us to return the maximum number of consecutive ones if with flipping k uh zeros, right? Cool. So based off this problem here, I already have copied this over to a SkeleDraw, and I would always suggest that you do this as well. This will help you with being able to take notes at the same time. So basically, I am gonna kind of model what this is doing, right? All right, this needs to move. How do I get it to move? All right. Anyway, let's do this. We'll just move it right there. All right. And we'll just bring it up and then we'll make it a little bit bigger so we can see. All right. So basically, what we want to do here is we're given an array, and let's do a smaller case, right? I mean, we could always do like the base case right there, but that's a pretty big case, right? So basically, what we want to do is because we're working on sliding window technique, and of course, we're going to have a left and a right pointer, right? And it looks like, and we'll go back to our notes here, and we'll look at the constraints first because I don't want to get too far. They give us the constraints, so right here I'll just put NA. But in a interview, you'll want to ask, um, is the array? I know you said it's a binary array, but is it just going to be ones and zeros, or the ones and zeros in a string in the array? Could I receive an empty array? Right? What did you want me to return if I receive an empty array? And k is equal to 1, right? You want to ask those questions, right? But right now we'll put constraints to that. So edge cases, of course, um, and I don't have to write this out. Empty will return probably nothing, right? Return none, right? And then if it's if if the length of nums is equal to 1, then we'll return 1, right? Because it doesn't matter if it's a 0 or a 1, k is going to be more than 0 regardless. So we can still flip at least 1 0, right? So if length is 1, then we'll return 1. All right, they take care of edge cases. Um, match, I forgot to put that down there. So match is basically what we concluded, right? Sliding window, right? And so let's look at the keywords here. So keywords, which is so important to understand. So keywords, maximum, right? So that means we need to keep a variable, right? We need to have a variable for maximum possibly, right? Um, consecutive, that means, you know, window. That means subarray, right? So we always want to define these keywords because it's going to help you match particular algorithms, right? All right. And then flip. So flip basically means that as long, I guess, as uh, the amount of zeros, and we'll walk through the problem, is k, I can count them as ones basically, right? And that's probably it's a little bit more probably complex than that. But for me, that's how I take notes. So you got to take notes for how you take notes for yourself. And we'll wait to come back for plan because we want to walk through this problem. So basically, um let's do max length here, and we'll make a variable for it. So I'm just going to use slashes for the length. And then what else do I need? Uh let's go back here. So max consecutive, I got my left and right pointer that I'm gonna use. And the flip. This is what we have to account for. So zeros. All right. All right. So basically, all right. So we'll go through this small case. This is a good way to build yourself up to that type of case, right? So say for instance, if k is equal to 1, right? All right. So right now we're valid, right? So max length is 1. We can move our right pointer. I don't know why I did that. I don't know why it does that with R's every single time. Hold on, y'all. Um, extra large. Let's do R. All right. So this will work. All right. So we can move that over here. So this is not a 0, so we don't have to worry about that. So we still can go up 1. So that's 2. Max length is 2. Go back in. That's not a zero. We don't have to start accumulating zeros. My length is 3. And then I accumulate a zero, right? But it doesn't change anything, right? Because long as I don't get more than 1 0, I'm flipping this basically to a 1, right? And I'll write it above because we're probably going to run into a case where we can't, I'm not going to erase this and make it a 1, right? And then what we'll do is, I forgot to mark. So we got another one. And then, of course, we'll move over. We'll move over the right pointer and pretty much the whole array, right? So we return max, which would be 5, right? Cool. That's an easy case right there, right? So, but as we can see, gets a little bit more dynamic than that. So what we'll do is we will shrink this a little bit because we know what it is, right? And we'll erase this right here. And I'm gonna build me another R and all that. Oh my goodness. Let's do this. Alt Z. All right. So I could have really kept that array and just moved it over. Let's do this. All right. All right, cool. So let's use this. Let's use that exact example. All right, make sure I draw it big enough where we can get everything in there. 1, 1, 1, 0, 0, 0, 3 zeros, 1, 1, 1, 1, and my drawing is going to HELL and back. All right. And so K is equal to 2. So we'll use the same variables. We'll use 0. Zeros equals to, well, I'm not going to put a number there because we're going to mark max length, I think. Yep, that's what we use, max length. Right? And then we use, okay, going back to text, right? And so going back to text, we use the R, and then we use L. I hope they ain't gonna be on the same thing. Yeah. So let's mark that out of the way. And then over here, let's put an L there. All right, this should be different. Okay, cool. So I'll make it bigger, and I'll make this bigger. See, we problem solvers. We make these things happen, right? Cool, cool. All right. So we're gonna walk through this problem pretty fast. I don't want to hold you all night. I think it's just very important to walk through these things. So we're valid, so we can go ahead and mark 1. Maximum length 1. We're gonna move right forward. Maximum length 2. All right, we're gonna move right again. Maximum length 3. And I did a similar problem to this. And then we're going to move this forward. All right, we got 1 0. Got 1 0, and we can get up to 2, right? So our length is still going to accumulate to 4 because we can flip this to a 1, right? And I'll put like, I guess the representation up there, right? And then we're going to move, right? Okay, we're at 2, right? We're at 2. And so this and this, we can't get any more zeros because if we do, then we got to move our window. All right. So let's see, R here, we move here, we're at 3. 3 strikes you out. 3 strikes you out. So we're at 3. All right. So basically, are we still at 3? Yes, we are. Are we still at 3? Yes, we are. Are we still at 3? Yes, we are. we still at 3? No, we're not. So because we're not again, I can take this one off because our window, bless you, our window passed it. And so now we can flip this to a 1, but I mean, they still kind of zeros, right? There's still 2 zeros inside of our window. And so, but the thing that we can do is now we can start back accumulating again. So our first max was 5, and we'll make a record of that. First max, so we'll say first equals 5. We'll count the rest of them too. All right, now we're already at 2, right? Because we can flip this and flip this because K is 2. So we're going to start off with 2 zeros, but we're going to have a length of 2. All right. And so what we'll do is we'll move this. Length goes to 3. 0, we still good. And then we'll move this. Length will go to 4. Right? So we're still good. And then length to go to 5. And so we're still good. Length to go to 6. And guess what? We're still good. Then length to go here. And then we're back at the 3-0 scenario. So guess what we got to do? We got to move our left again. So let me make sure that I mark this, right? We at 3-0 still. And so what I'm going to do is no, we're at 2 zeros now. So I can erase this. 1, 2, 3, 4, 5, 6. We already have 6. It does not beat the max. So this is what we returned as the longest. Now let's go implement the plan. So the plan is create max length variable, left and right corner. And what else did I use, y'all? Oh, zeros and zeros variable. Okay. We'll say iterate through with right corner until it accumulates uh more than K zeros. Yeah. So we're gonna accumulate the right pointer until because you can have a case. So this is another case, right, to think about. So I don't think, yeah, it does show it there, don't it? So if you started off with zeros, right? So say for instance we started off like this, right? And let's roll this down. And so, we got L here, we got R here, and and then yeah, and so max length length here, and then zeros here. All right, I'm not gonna write all that out. And then let's say K equals 2, right? So basically, we don't have anything here, but we do accumulate 0, right? Cool. And then what we'll do, we're gonna grab R, we'll go to the right. We don't have nothing in length. Oh, no, 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 no. Matter of fact, we could flip. Okay. So, matter of fact, let's go back here. So I can flip this, right? Because max length, right? And then I go here again, and we're gonna move. Boom. We're at 2 zeros. Cool. Max length is at 2. and then we move R again. Now we're at 3. So it's 3 strikes you're out, and we'll make the representation of the ones that we did earlier, right? So it's 3 strikes you're out. Now we have to move L. So L has to move until we're valid again. L moves, we're back valid. We can turn this into a 1. We remove the 0 that we passed. Now we're back at our case that keeps that loop moving. And now we go from, we got 2 and we at 3. We're going to make a mark here. And we at 4. Go here. Cool. And we know because the rest of the length is 3 because it won't accumulate more than 4. So basically the answer here would be returning this. Okay, cool. All right, y'all. So let's go back. So we already made the plan. I think we just implement the plan, right? And I like to do it up here where I can see the actual okay. So we're gonna create max length variable. So max length variable equals 0. And we're gonna do something with that pointer. Left equals 0, and then we're gonna put zeros equal 0. And then basically we're going to use the right pointer to iterate. Well, matter of fact, let me do this because I don't like to, I mean, this is just a common thing that you'll see length of nums here. And so for R in range of n, right? And then we'll say while, no, matter of fact, yeah. Then we'll say while zeros is more than K, what we need to do. So while zeros is more than K, okay, yes. So if nums 0, I mean nums right, our right pointer, if it equals 0, no. We accumulate zeros. You know what, I'm tripping. So if nums right equals 0, then we got to accumulate the 0, 1. And then while zeros is more than K, right? And if, so that base case when we was moving the L, not base case, but the case right here where L will have to keep moving, right? So basically if, bless you, nums L equals 0, then, so if num L equals 0, we want to take away the 0. And then we want to move the pointer forward, right? And then here, this is almost every single sliding window technique is, I think this is it, y'all. Width equals right pointer minus left pointer plus 1, right? That's a window, and then max length will be, will be the max of itself or windows hold on. Hold on. I'm not doing something right, I don't think. So if R equals zero, that's cool. We know that. And while zeros is more than K. If L, then we subtract one and then we move it forward. And then here, matter of fact, this is gonna go back one, right? Because we're not gonna, this is our else block, right? We're not gonna do, because this is else, right? This is gonna move the L plus one forward. This is gonna calculate the active window. This is where we store any previous maxes before. And then of course, I think we're just gonna return here. We're gonna return, if I can spell, max length. Gonna return max length. Let's see what we get. Runtime error, zeros, cannot access variable zero. Oh, zeros. Okay, we passed the base case. Cool, we walked through that thing, and now we're gonna submit and see if the hard work we've been putting in. Okay, we beat 81.61%. Thank you so much for tuning in. Make sure that you utilize Excalibur. They're not sponsoring me yet, but make sure you utilize them so you can walk through and drive run through problems. That's the most important thing. My next one will be on linked lists. This is what I've been learning a lot about lately, and hopefully you stay in tune for that. Thank you so much.